Okay. Make sure your audio is off and your audio output is off if you are in the classroom. Everybody should be muted. Okay, good. Chat. All right, so go ahead and make sure that your name is correct and on the right spot on the seating chart. Really, really important that it is right. One of the things that I think a few people were doing is they were typing into the Excel spreadsheet, into this spreadsheet, and then they didn't either click outside of the box they were typing in or hit enter. And so then it just didn't save what you typed. So make sure when you're typing something in, that you type it in, you exit that box, you know, like click on a different box and then close the window. And you should always go back and check and make sure, like, you know, close the window and then reopen it up. Is it really there? What I was planning on typing, right? Okay. So about time to start. So I'll start today with an amazing joke, high quality stuff. What do you call a sleeping dinosaur? A dinosaur. Dinosaur. Good stuff. All right. So you should see that I am running an iClicker question right now. And the first iClicker question is just attendance. Are you present in the classroom or are you remote at home? So everyone should respond to that. We got 49 responses. It kind of tells me how many people are here today. So if you have a handheld remote, you should be on, I believe, AA. Anybody with a handheld remote able to use it? Yes? Yes? Okay, good. Any problems? Because we're going to use it again in just a minute. Good. All right, I'm going to let it run just while we get settled. Okay. And if you're using the app, it sends a picture of that question to your phone. So it's kind of nice that you get to see it right in front of your face. Okay. So my reminder for you guys is that you have some things due, right? Pretty soon. What's coming up that's due? You have a mini homework that is due Friday at midnight. And mini homework A is on the MyLab and Mastering online system, right? So if you have not been able to access the online system, you need to ask for help, either me or the Pearson site or the bookstore. Are you using Google Chrome? Nope. So for the online system and for Moodle in general, for the rest of the time that you're here, if you're trying to access something that's university related, use Google Chrome. Close Safari, exit out of Safari, completely close it, and then reopen Chrome and go through Moodle and do all the things you're supposed to do. Moodle works the best with Google Chrome. So from here on out, use Chrome. Anybody else? Good? Okay. All right, and then what is due? Again, you have one more thing that's due before you see me. It'll be chapter 1 homework, which is due Monday night at midnight. Okay, questions? All right, good. Okay, so that was my reminder. All right, so we are ready for some iClicker stuff, right? And everybody's good on the chat, nobody on the chat. All right, so before I show you an iClicker question, I think I forgot to tell this class. For the iClicker, remember we went over the syllabus and it's gonna be like 100 points, like a regular exam score. But I forgot to tell you the best part. And the best part is that normally, what do you have to make an A? A 90%, right? For iClicker, A 70% is an A. So it's like a 20-point curve. But the reason I do that is, number one, you're not going to get everything right. It's okay, you're still learning, right? Number two, you might be absent. You might have technology issues. I don't do makeups on iClicker questions. So there's no way to make it up, but I give you a 20-point curve right off the bat. Okay, make sense? So if you're going to be out, it's okay. There'll be plenty of other opportunities to get points. We'll do it every day. Okay. All right. So I'm going to show you an iClicker question. I want you, full screen. We're going to do this. All right. I'm going to stop. Looks like we got 53 people. I'll stop this one. Okay. Now, do not talk to your neighbor, but you may use any resource that you have in front of you. Whatever, don't Google, but you can use your notes. You can use your notes on your computer or whatever it is, right? Which of the following is not a pure substance? I'm going to give you 1 minute. 1 minute. Which of the following is not a pure substance? So remember, 1 minute. And never leave anything blank for me. Always take a guess. Always better than leaving it blank. Okay, you got about 5 seconds left. These are supposed to be questions you kind of already know the answer to. I'm going to give you another couple of seconds. It should be 53 responses because we had 53 people checked in. So trying to wait nicely, but I'm not going to do it in the future. Okay, so everybody put in an answer. Now, this is how I'm going to do it. I'm not going to tell you the answer yet. I'm going to give you another minute, but this time, talk to someone. What did you put? What did they put? What do you think? And then I'm going to let you answer again. Okay, ready? All right, go. Keep your mask on, but you have to keep your mask on. I know it's hard, but keep your mask on and don't get up. Okay, getting close. 5 seconds. Don't forget, you got to click in again. So don't forget, you have to click in again. So I'm giving y'all some extra time because I see some people haven't clicked in for a second time. So make sure you click in for a second time. So you're answering the same question basically twice, right? Once by yourself, once with your friends. We had 52, 53, something like that. We got a few people who need to answer. Come on, y'all. I'm going to end it in 5 seconds. 4, 3, 2, 1. Okay. All right. So let's see what our results were. People said gasoline. Great. Okay. What did we say the first time when you did it by yourself? Look, we only had 55%, but what happened when y'all talked to each other? Oh, we did a lot better, right? Okay, so y'all are right. Gasoline. Why? What is steam? It's water. What's the formula for water? Does it have a chemical formula or chemical symbol? Yes. So is it a pure substance? Yes. Ammonia. You might not know ammonia has a chemical formula, but it does. It is one substance. Iodine crystals. Is there anything else in iodine crystals? It's just iodine, right? So it's I2. You didn't have to know it was two, but just have to know it's one thing, right? What is gasoline? It's a mixture. It's absolutely a mixture. It's a mixture of hydrocarbons. All those dinosaurs that have turned to broken down bits and hydrocarbons. You're putting dinosaurs in your gas tank, basically. So all of these things have one chemical formula, except for gasoline. Gasoline's a mixture of stuff, right? We said last time you could even have ethanol inside of it, right? We talked about that as an example, right? Okay, let's try one more. Okay, oh, I'll put the answer there. All right, so here we go. Which of the following substances can be classified as a homogeneous mixture? So now I'm telling you, out of all of these, which one is a homogeneous mixture? Give you 1 minute. I'm really cutting it off at 1 minute. I'll give you a 10-second warning. Okay, 10-second warning. Make sure you don't leave it blank. All right, 1 minute. All right, so now I'm going to give you that same question, but now talk to your neighbors. And then re-enter your answer. I guess I'm sorry, those of you on Zoom just get 2 tries. Make sure you click in for the second time. Okay, 10 seconds. Make sure you click in for the second time. Closing it soon. Okay. So which of the following, what did we say? Good, good, good. All right, let's see how we did. That's 91%. That's great. Look, y'all do so much better when you talk to one another. I like it. So this is the first time I do it where you turn it and talk to your neighbor. So I'll have to let me know how it kind of goes. But you're absolutely right. Salt water is a homogeneous mixture. What does homogeneous mean? Same throughout, right? So oil and vinegar. No, what happens with oil and vinegar? It separates. It's like salad dressing, right? Yeah, you get that layer of oil at the top, right? So this is what kind of a mixture? Heterogeneous. G-E-N mixture. I was going to abbreviate and I didn't. Hydrogen. Is that a mixture? No, what is it? It's a pure substance. It's H2. It's a pure substance. How about water? Another pure substance, right? It's got a chemical formula. Okay. So reason through it. When you're looking at these, if you have to look at the words and then define for yourself, what is a homogeneous mixture? Then go and look at the answer choices. That's okay. If you want to write next to the answer choices, This is what that is, right? Sometimes that'll help you on a test. So those are all good, good test taking tips. Okay, we might do a few more later, but I want to go back and work on some more of our problems. And we were here. Okay, view full screen. Maybe. All right. So the last problem we did should have been, we were talking about physical and chemical changes, right? Yeah. Okay. So physical changes, do you change the chemical composition? No, you don't, right? It's still water when it goes from liquid water to steam. So that's a physical change, right? But we can have chemical change, and we talked about the different things that we can observe to indicate a chemical change has happened. But by definition, what has to change in a chemical reaction? The chemical structure of the stuff, right? So we're looking here at kind of a pictorial example of a chemical reaction. So it's just abbreviated with spheres, right? So this is an example of a chemical reaction. So on the left-hand side, what's all this stuff? What do we call that? Reactants. Reactants. Y'all heard that before? Yields, that's what the little arrow is. And we yield what? Products. Okay, so if we look at those reactants, we have silver spheres and red spheres, right? So the name of the game when you write out a chemical reaction is that you cannot play God. You cannot create or destroy matter. We just don't have that power. So it'd be cool, but we don't. So whatever's on the left has to equal whatever's on the right, because you can't create it. You can rearrange it, but you can't destroy it and you can't create it. So if we look at A, if we look at the silver spheres, how many are on the left? 2. How many are on the right? 1. Is that equal? No. Can I destroy one of these? No, I don't have that power, right? I'm not that good. So what could I do? I can put some more on the other side, right? So I could draw it. I could draw a silver. I don't have a silver, but I could draw it. But it has to stay together, right? If I make one more of the gray, I have to make 2 more of the red, right? I can't make a new product. I can just make more of what I already have. So by doing that, now do I have the same number of grays? Yes, I do. I have the same number of grays. Do I have the same number of reds on each side? No. So what am I going to do? I need to add more reds. How many more reds do I need? I have a total of how many on the right? 1, 2, 3, 4. Y'all see that? So I need 3 more, right? 1, 2, 3. That would give me the correct number. Okay. That's visually what happens. This is how we make that reaction happen, right? We have 2 silvers on the left. We have 2 silvers on the right. We have 4 reds on the left, 4 reds on the right. But that gets really messy if we write it that way. So do you see what those little blanks are? We can use what are called coefficients. That's what goes in the blank. It's called a coefficient. E-C-I-E-N-T, coefficient. So we put that number in the blank and it multiplies however many atoms of something we have. So if I want to have a total of 4 red spheres on the left, what number do I put in the blank? Remember, it's multiplication. So if I have 1 red, what do I put? 4, because 4 times 1 is 4. Okay. How many what do I put in the blank on the right side? I put 2, because 2 times 1 silver is 1 silver, and 2 times 2 reds is 4 reds. What do I put in that first blank? Typically we put nothing, and nothing stands for what? 1. So 1 is basically understood, so you don't have to write it unless it's like a multiple choice question. It says, you know, like which of these are the correct coefficients? And it'll be like 1, 4, 2, and it'll be there. It's just, if there's nothing there in a chemical reaction, it's really a 1. So if somebody asks you, you could say 1. I won't mark it wrong if you put a 1. Okay. All right, so let's look at the next one. Let's try not to draw underneath. Let's try just to look at it. Do my dark silver spheres, are they equal on both sides? Yes, okay, so we can leave those alone. Are my light silver the same? Are my red the same? Are my green the same? Yeah. So what do I put? Just put 1s. I'm balanced, right? Okay, if we take this and we turn this into, I'm gonna erase this stuff, into the way we normally write chemical reactions. If I call this gray, I'm gonna call it X. And I'm gonna call this red, I'm gonna call it Y. Can't really see that. I guess I'll do it in blue. I'll call it Y, right? So that means I have X. Now, where do I put, how do I designate that I have 2 atoms of X? Subscript. Remember how we did that just, let's go back one. We did it here, MgSO4, how many atoms of oxygen? 4. So how many atoms of X? 2, so we put that as a subscript, right? Plus, I'm going to put my Y in. How many Y's do I have? 1. So it would be a subscript 1, but I'm not going to write it because 1 is understood. I'm going to say yields. Now, how do I put the symbol for this? I have 1X, right? And how many Y's? 2 Y's. Yeah? So now if I'm going to balance this, I'll balance it with, I guess, blue. I have to say that I have 2 X's here and I only have 1 here. So I'm going to put a 2 here because 2 times 1 is 2, right? And then I say, okay, now 2 times 2 gives me 4 Y's. So then I need to put a 2 here. See how we did exactly the same thing, but we're converting it from a visual picture to the letters. Does that make sense? Yeah? No? Let's practice. Let's practice. Okay, let's balance some of these. And I should have given way more room, huh? Okay, I'm going to come down here. I'm going to do 1.16, but I'm going to come down here and do it where I have some extra room. Okay, so this is 1.16. I have NO2 plus H2O. What are all those letters I'm not writing that are in parentheses? Do you see that? G, L, what is all that? States of matter. And we're not really worried about that right now. So I'm not even going to worry about it just so that it doesn't clutter up our screen here. Okay, so I have NO2 plus H2O yields HNO3 plus NO. Okay. I'm going to give you a hint here. Look at this problem. Do you see how oxygen is everywhere? It's going to be a pain to balance. So pick an element that's not in multiple places and balance that first. So what do you want to balance? Let's balance H. How many on the left? 2. How many on the right? What do? I want to multiply this one by 2. It's a really weird looking skinny 2. right? Because 2 times, it's understood that there's a 1 there. 2 times 1 is 2. Okay, so I'm going to erase that 1. I want to get you confused. Okay, so now my hydrogens balance. How about nitrogens? How many do I have on the left? 1. How many do I have on the right? 2, because 2 times 1 is 2. Okay, so how do I fix that? They're not equal. How do I fix it? Put a 2 over here, right? Now 2 times 1 is 2, and 2 times 1 is 2. So I'm equal. Y'all agree with me? Yeah? Kinda? Oh, what about the N over there? That's a great question. Okay, so how many do we really have? 3. So I have 2 times 1 is 2 plus over here. So my N over here is really 3. So how, well, if I multiply this one by 3, let's try it. If I multiply this one by 3, what do I get? So I have 2 there, that's good. So here I have 3 here and I have 3 here. All right, how are my oxygens looking? Close that. How many do I have on the left? So let's do oxygen. I have 3 times 2 is 6 plus 1 is 7. Over here, 3 times 2 is 6 plus 1, 7. Am I balanced? Yeah. Just make sure you remember that elements can be in multiple places on one side of the reaction or the other, right? So make sure to catch them all. Okay, all right, so that was A, right? That was A. Come down and do B. Okay, B. NH3 plus O2 yields N2 plus H2O. Okay, what do we want to do first? Oxygen? Doesn't matter. How many do we have on the left? How many do we have on the right? 1. Okay, so what do we do? Add a 2 over here. So now 2 times 1 is 2. Okay, now what? Nitrogen. Okay, so nitrogen, how many do I have on the right? 2. How many do I have on the left? So what do I do? Multiply by 2, because this is really a 1 right there, right? So 2 times 1 or 1 times 2, same thing, it's 2. Okay, now what? Hydrogens, right? How many hydrogens do I have on the left? 2 times 3 is 6. Okay, how about oxygen over here? Not oxygen, hydrogen, sorry. 2 times 2 is 4. Uh-oh, what am I gonna do? What am I gonna do? I need to change some coefficients. What am I gonna change to? Put a 3 on which? A 4 in front of what? You're not going to come up with the right. It's not going to be, they're not all going to be equal. What's another? Look at your other elements though. Your other elements aren't going to be equal. Okay, so look at your hydrogen. Our hydrogen is a 6, right? A 6 and a 4. There's nothing I can multiply to make 6 equal to 4, right? Or 4 equal to 6. I can't multiply 4 times 2 is 8, right? 8 doesn't equal to 6. So I know I'm going to have to increase that coefficient, right? So what number is a multiple of 6? 12. So what if we make hydrogen 12? How do we get 12 hydrogens on both sides? 4 on the left. 4 on the left. And 6 on the right. Okay, how does that change everything else? Like you got to go back and recount everything. So our hydrogens, let's fix our hydrogens. I'm going to erase this stuff and I'm going to recount our hydrogens. So 4 times 3 is what? Okay, so 4 times 3 is 12. Hydrogen over here, 6 times 2 is 12. See, that's what I'm going for. I'm trying to get these to equal. Okay, so now which one you want to do? Nitrogen. So nitrogen is 4 times 1 is 4, right? So nitrogen on the other side. 2 times 2 is 4. So we need a 2 here. Okay, now what? Oxygen, right? So oxygen over here, I have on the product side, I have 6 times 1 is 6. So what times 2 gives me 6? 3. When you're done, look at all your coefficients. Can you reduce all these coefficients in any way? No, you can't. If you do it, sometimes you'll do it wrong, but you'll get like 8, 6, 4, and 12. 8, 6, 4, and 12 is the right ratio. But if you're doing a balanced chemical equation, what can all these numbers be reduced by? Divide by 2. If you can divide everything by the same number, you have to. Divided by 2 gives you 6, right? So you have to give the lowest ratio possible. Okay. All right, we got one more on this, right? See? I need to move this. Can't see my extend screen. There we go. Okay, C. What do we got for C? C7H16 plus O2 yields CO2 plus H2O. Do you want to start with oxygen here? No, because it's in multiple places. Pick something that's not in multiple places. Carbon. Carbon's a great place to start. How many carbons on this side? 7. How many carbons on this side? So what do I do? On the product side, put a 7 in front of the carbon. Now let's worry about what? Hydrogens. How many hydrogens do I have on the reactants? 16. How many hydrogen do I have in the products? 2. I want to get to 16. What do I need to multiply by? 8. I should have done this. Okay. Now we can tackle our oxygens. So how many oxygens on the reactants? 2. How many oxygen on the products? 7 times 2, which is 14, plus what's in water. So 8 times 1. What do we get? What is that? So I need to multiply the reactant side by 11. And I get 22. Yeah? You got this. You can do this. I put an extra tutorial on balancing chemical equations in Moodle right under the chapter 1 material. So if you need more practice, there's an extra tutorial there. Okay? All right. So now we're going to switch gears and we're going to do some math. There's something I love not quite as much as science, it's math. Okay, so I think I skipped too far. Did I skip too far? It's too excited. Here we go. All right. So in the lecture, right, you watch the lecture, there are lots of rules to counting significant figures in science, right? Because you have to think about, somebody's going to measure something and get a number, right? But how precisely did they measure whatever that was? There's a limit, right? We can only be so precise depending on what kind of tool we use to make the measurement. So that has to be reflected in the data that we collect and the data that we present and in how we manipulate those numbers using math. So significant figures is huge, is so important, but it's a lot of rules. But I have this little way to remember significant figures, right? So I always say, what's the best country in the world, right? The United States of America, right? So do you remember your oceans that flank the United States? The Pacific Ocean and the Atlantic Ocean. And remember, the United States is awesome. So everybody wants to get into the United States, right? So that's what these arrows are. Everybody wants to get into the United States. So this, if you write this little thing on your paper, you're going to get it right, because the P stands for in a number if the decimal is present. The A stands for decimal absent. So if you take any given number, like A here, do I have a decimal present or absent? The decimal is present. I see a decimal, right? 0.00, that's the point. So what you do with your arrow is you cross out zeros until you get to your first non-zero number. What's my first non-zero number? 6. Count every digit after that. Non-zero or not, count every digit. How many? 2. That's 2 significant figures. Right? Okay, 100 degrees Fahrenheit. Is the decimal present or absent? Absent. So which direction do we go? This way, right? And we cross out zeros until we get to our first non-zero number, and then we count all the remaining numbers. How many are there? 1. Yeah? Okay, C, 9,237, 200 years. 37,200 years. Ooh. Present or absent decimal? Absent. So we come in from this side, we cross out our zeros. Now we count everything else. How many? 5 significant figures. Okay. How about this one? Decimal present or absent? Present. What direction do I come in from? Decimal's present, right? You're always trying to get into the United States. So how many significant figures? 4, right? Because whichever direction you come in on, you cross out zeros. Did I have any zeros to cross out? No. So when I got to my first non-zero number, which was the first number, I have to count all the rest. So how many significant figures did y'all say? Okay. All right. Now, when we do calculations, there are rules that we have to follow. What are the rules that we have to follow if we're doing math with significant figures? Let's put our rules. I guess we can go back because I have more room over there. I'll go down. I'm not the best at using all this. Oh, and I used all that, but that's okay. We'll do this. We'll do rules, right? So if I have 2 numbers and I multiply them together or I divide them, Remember, your answer cannot be more significant than your least significant starting number. So what do I do if I multiply two numbers or divide two numbers? Doesn't matter. I guess I shouldn't do an equal sign, but like an arrow. What do I want to do? I want to count the number of the, let's do it a different way. Let's say count the number with the least significant figures. And that's how many significant figures are in your final answer. So if you looked at A, do you see an A here? I had one significant figure in 100 and then two significant figures in 23. And what did my final answer have to have? I counted the least. Here's my least, one significant figure. So my answer must have, whoa, how did I do that? Wow. My answer must have now one significant figure. Okay. But if you add or subtract, the rules are different. If you add or subtract, you're going to count the number with the, it's not least significant figures now. Now we're looking at the least, whoa. No, that's not what I wanted. There we go. With the least places past the decimal. Those are our rules. It's basically two rules. So look at D. Look at D. 54.00 had how many places past the decimal? 2. 78 had none. So my answer, if you put it into the calculator, you get 132.00. But is that right? No. My least number of places past the decimal was none. So my final answer should be 132. Okay, so let's try some new ones. Are we multiplying, dividing, adding, or subtracting? We're dividing, so we're counting significant figures. So 340, how many significant figures? 2. 96, how many? 2. So what should my final answer be? 2. So put it into your calculator. What do you get? Come on, calculators out. Everybody should have a calculator. Even if you have to do it on your phone today, but everybody should have a calculator every day from here on out. Put it in your calculator. What do you get? 3.5416. Repeating, right? Okay. Can that be my answer? No. I need two significant figures. So you have to round. Remember your rounding rules. If I want two significant figures, that's 3.5, but I have to look behind the 5. And if I have a 5 or above, it rounds up. If I have a 4 or below, it rounds down. So what do we have? 3.5. Okay, B, what are we doing? Addition, subtraction, multiplication, or division? Addition, so we're looking at places past the decimal. 0.305 is how many places past the decimal? I'm going to say 3 places past the decimal, PPD, because I don't have room. How about 43.1? How many? We only have 1, right? So what's my final answer going to have? 1 place past the decimal. Okay, put it into your calculator. What do you get? 43.3. Tell me what your calculator gets. 305. Now tell me what the correct answer is. 43.3. I want everybody to see what we actually get in the calculator and then what you have to round it to, right? All good so far? Okay. 0.0065 times 11. Are we doing places past the decimal or sig figs? I call them sig figs. They sound cooler than significant figures. I call them sig figs. We're looking at sig figs. How many sig figs in C? We have 2 sig figs. How many in 11? 2. So what should my answer have? 2. Okay, put it in your calculator. What do you get? 0.0715. But that's not 2 sig figs. How many sig figs is that? 3. So what do I need to do? Now be careful. I want 2 sig figs. So that's going to be the 7 and the 1, but look behind the 1. 0.072. Okay, D, am I looking at sig figs or places past the decimal? Places past the decimal. How many do I have in 19.092? 0.09, 0.029. Oh my gosh, if I could read. How many places? 3. And how many places in the next one? 5. So what should my final answer have? 3 places past the decimal. Put it into your calculator. What do you get? $19.0 what? 99, is that what y'all got? Okay, so I want 3 places past the decimal. What does it round to? Okay, good. All right. Let's see. Next one, we're going to be doing, raise your hand if you have done, depends on what teacher you've had, they call it different things, dimensional analysis or a factor label method. Some people, yes. Okay, so all that is we are converting units, right? And it's all about things being equal, right? If I told you that in my refrigerator, I have 24 eggs. How many dozen eggs do I have? 2. You can do dimensional analysis if you can do that, because I know that 1 dozen is equal to 12, right? 1 dozen eggs is equal to 12 eggs, right? So when I do dimensional analysis, I call it the fence post, right? I put fence posts, I draw my line and I just do fence posts. What I want to do is I want to get rid of 1 unit and convert to another unit. So I want to get rid of eggs. In math, if you have something in a numerator and you put the same thing in the denominator, what happens? They cancel out. So if I have eggs in the numerator, where do I want to put eggs? In the denominator. Then I'm going to put my new unit on the other side. So I'm going to put my new unit of dozen eggs here. Now all I have to do is fill in the numbers. So I knew it was 12 eggs per 1 dozen. So what happens to eggs? Eggs cancel. I'm left with what unit? Dozen, right? So now I multiply everything on the top. I get 24, right? 24 times 1 is 24, divided by what? 12. And we're left with dozen. So what do we get? 2 dozen. Okay. That's all we're going to do with conversions. And I'm going to erase that if that's okay. But the important thing is that you used this relationship, this equal relationship, to make dimensional analysis work. And that's all we're going to do with it. Okay, so we got to do 1.22, right? Get rid of this stuff. Okay. So 1.22. An average adult lung volume is 5 liters. Convert to milliliters. Do you have to remember every single conversion? No. What do you have? In your exam resources, SI units and some useful conversion factors, right? So I want to convert liters to milliliters. I need to find an equivalent relationship. So where is that on here? I'm telling y'all, make friends with this exam resources. You need it to be your best friend. Right in the middle, metric prefixes. Kilo, base unit, deci, centi, milli, micro. What's the abbreviation for milli? Little m, right? So milli means 1,000. So what's my relationship? In 1 liter, always put your units, I have 1,000 milliliters. The milliliters, tiny, right? A liter is like a liter of Coke, right? That's a lot. So you have 1,000 milliliters in 1 liter of a drink, right? Okay, so now I have my equivalent relationship. All I'm going to do is fence posts. What do? I want to get rid of liters. Where do I put that big L? On the bottom. And I want to get to milliliters, so I put that on top. Now I just put in my numbers. Where does the 1,000 go? Top or bottom? At the top. Be careful. That's where a lot of people go wrong. So 1,000 goes on the top, 1 goes on the bottom. So how many milliliters? 5,000. And that makes sense, right? Get a lot of something small in one big thing. Yeah? Okay, we're going to do that so often. So often. All right. Next one is scientific notation. I actually was teaching, so yesterday we got pizza for dinner because life's crazy, right? So we were sitting in Papa John's waiting for our pizza. And I don't know, my son started asking questions. He was writing numbers and he has to like learn how to say these really long numbers, you know, because he's in the 4th grade. And so then he wanted to know about exponents because he was playing with my calculator and it showed exponents. So yesterday in Papa John's, I was teaching my 4th grader scientific notation. Fun. All right. So A, look at A, that's a really long number. And so a lot of times in science, we don't want to have to put all these commas and all these extra zeros. So what we do is we represent it as a multiple of 10, right? When you have a multiple of 10, all you're doing is moving the decimal place. So where's my decimal normally in this number? Behind it, right at the very end. So now if I want to put this in scientific notation, I'm going to say it's going to be some number between 1 and 10 times 10 raised to a power, right? So how do I get a number between 1 and 10 just by moving the decimal? I'll get 1.4, right? I can't do 14 and I can't do 0.1. Neither one of those is between 1 and 10. Times 10 raised to some power. The power is all about how many times you move the decimal place. So all I do is count. 1, 2, 3, 4, 5, 6. I move the decimal 6 times. Now, if I move the decimal this way to go from a big number to a small number, my exponent is going to be positive. How many times did I say? Thank you. I start talking and forget where I was. So that's a positive 6. If I start with a number that's small, like in B, and I make that bigger by going to 7.9, now what's my exponent going to be? It's going to be negative. So now I need to know how many times I need to move it. I move it 1, 2 times to get to 7.9. So this is -2. Cool. All right, let's do the last one. What's going to be my coefficient? What's going to be my number between 1 and 10? 3.54. Okay. How many times do I have to move the decimal place to make that happen? 6. I get 6. Do y'all get 6? Times 10. Write your little humps. Write them. What did I say? 6? Is that a positive 6 or a negative 6? That's negative because the number started out less than 1. Okay. Now we're going to go backwards. Right? 7.4 times 10 to the negative 2. If you see a negative, I want you to think, oh, that's a small number. That's a number less than 1. So what direction do I move my decimal place 2 times? Left. 1, 2. So I'm going to say 0.074. Always put your 0 in front of the decimal in science. Always. Okay, B. Is it going to be a big number or a little number? Big number. So we're going to have to move it to the right 3 times. 1, 2, 3. So 3750. 3,750. Okay, oh my gosh, look at C. Really big or really small? Really small. I got to go negative 8. Oh my gosh. Okay, you ready? 1, 2, 3, 4, 5, 6, 7, 8. So that'd be 0.567 and then 8. So if it's a negative exponent, the number of zeros between the decimal and the number is 1 minus that, right? So it's, I'm not counting this 0, but I'm saying these zeros, there's 7 of them. Yeah? Okay. Express the following numbers in decimal form. We have an asthma medication, 1 times 10 to the negative 8. What should our answer be? Negative 8, we put our decimal, and we're going to put how many zeros? 1, 2, 3, 4, 5, 6, 7, 1. Am I done? Why not? Before the units, there's something else. The 2 zeros. Is the decimal present or absent? Present. So I come in this way, start counting at my first non-zero number. How many significant figures? 3. Do I have 3 significant figures in my answer? No. Now, do I have 3 significant figures in my answer? Yes. Did y'all see that? It's a little bit tricky. Now, what else am I missing? Units. Units. Never, ever, ever, ever forget the units. I love the units. So you know my little catchphrase? Tag, tag, tag. Make sure you label your numbers. A number without a unit does you no good whatsoever, right? Do I know that? Is that grams? Is that milligrams? Is that kilograms, right? You have no idea. You have to put a unit, okay? All right. Vitamin D dose of 5 times 10 to the negative 6 grams. So negative 6, is it going to be a big number or a small number? Small number. So you're going to be less than 1. So if it's to the negative 6, I'm going to put 1, 2, 3, 4, 5, and a 5. Am I done? What do I put? A 0? And grams. Oh, y'all are so awesome, right? You got it. Okay. Let's see. We got next. All right. Express the following numbers as a percent. How do we convert from a decimal to a percent? That's supposed to be a percent sign, not a 9. How do we do that? What do we do? All we do is take the decimal times 100 and we get the percent. Right? Okay, so what do we do? 0.58 times 100, what do we get? 58%. Do I have the same number of significant figures? Yeah, I do. I do. Sometimes I just like to ask y'all, just for fun. So what do I do for B? I know I'm crazy how I get my kicks. Times 100, what do I get? 36%. Okay, how about C? Do I have the same number of significant figures? Yes, I do. Yes, I do. Okay, now, if we want to go the other way, if we want to go from the percent to the decimal, now you just got to do the opposite. What's the opposite? Divide by 100. So I'm going to divide by 100. What do I get? Dividing by 100 is just moving the decimal place twice. What do I get? I get what? 0.2. Okay, so now I'm representing this as a decimal. How do I represent this as a fraction? Because that's really what the question asks. 1/5, right? Because the same thing, 20 divided by 100, I can cancel zeros, right? 2 goes into 10 how many times? 1 and 5. So that is the same thing as 1/5. Right? Okay, 75%. You don't have to give me the decimal form. I just wanted to make sure you could do that. Give me the fractional form. 75 divided by 100. What can they both be divided by? 25. So if I divide 75 by 25, what do I get? 3, and then 100 divided by 25 is 4, so 3/4. Okay, how about C? 40 over 100. I can cancel my zeros, right? And then how can I reduce 4 over 10? Divide both by 2. What do I get? 2/5. And then D, I'll do over here, is 12 over 100. What could I do? Divide by what? 4. What do I get? 3 over 25. Not too bad, right? All right, let's see. Determine the percent from the numbers given here. Okay. So when you're reading a word problem, what's the same thing as is? Equals. Is the same thing as equals, right? So 50 is what percent of 125? So how do I do that? 50 is equal to some percent of 25. So how do I do that? I'm going to say what percent is going to be X over 100 times 125. Right? So how do I solve for that? Y'all, algebra is going to come back. You got to remember your algebra. I want to get X alone. What do I do? Divide by 100. So what I do, I don't know what y'all were taught, but what I do is whatever's on bottom, right? I put it on top. Whatever's on top, I put it on the bottom. And then what you do to one side, you have to do to the other side. So it cancels, and I'm left with 100 times 50 divided by 125. Y'all get that? And everybody learns algebra slightly differently. Is that what y'all got? Some way, shape, or form? But sometimes y'all cross multiply and stuff like that. Everybody has a different method. Doesn't matter to me, as long as you get to the same answer. So what is X? What's that? What are you getting calculators? 40%. Okay, good. All right, how about B? 6 is what percent, which is x over 100, of 600? What do y'all cross multiply and divide? Like you go this way, you do 6 times 100, it's the same thing. You do 6 times 100 and then divided by 600. Is that what you get? Is that how y'all do it? Doesn't matter. So what do you get? 1%, because 6 times 100 is 600, divided by 600 is 1. Yeah? Okay, C. What percent of 300 is 15? How do we set that up? X percent, right? X over 100 of 400 is 30. It was just kind of written backwards, right? So what do you end up with for X? Put it in your calculators. I love to hear calculators clicking. It's like my favorite thing ever. Yes, the calculator clicks. Yes, love it. What do you get? 5%. Okay, and then D, what percent of 400 is 30? So what percent of 400? Wait, did I do C and D? Did I switch C and D? I did. Okay, so this one was actually D. So this one is going to be C. Sorry, y'all. Of 400 is wait. Yeah, 300 is 15. Okay. So this should be 300 and this should be 15. Sorry about that. So what do you get? Throw it out there. What you got? What? D was 5. Oh, D's. Oh, that's what I did. Okay. 7.5. And this one is 5. Okay. That's swapped. Good. Okay. All right. Now we really get to some chemistry stuff. That was just kind of pure math. Now we get to applying some of that math to chemistry. So remember when we were talking about density? Yes, yesterday. I always like to say yesterday, but it wasn't yesterday. Last time I saw you. And we were talking about density and what kind of things will float, right? So if something's going to float in water, it is more or less dense than water. Less, okay? So based on your experience, if we drop a paper clip into water, what's going to happen to the paper clip? It's going to what? It's going to sink. If it sinks, what do we expect? It is more or less dense. It's more dense than water. Table sugar. When you sprinkle sugar into, do you remember, when I was a kid, we had the real Kool-Aid, right? And you had to scoop out way too much sugar in order to make it. So what would happen to the sugar as you pour it in to that Kool-Aid? It sinks. So it is more or less dense. More dense. Okay, how about ice? Ice is going to float, right? So it must be less dense. And this is like an insane concept. What is ice? Water. What is water? water is the only substance where the solid form is less dense than the liquid form. And we're going to talk about why, because it's like amazing, but a little preview of exciting things to come. All right. So how did we calculate density on that first day? How did we do that? I say when I calculate density, I like to go to the DMV. Density is equal to mass over volume. How do you like that? I'm going to the DMV. God, I hate the DMV. All right. So if I want to calculate density in grams per milliliter, I have 2 liters of gasoline that weighs 1.32 kilograms. What am I going to do? What are my units on density? Grams per milliliter. What do I have? Liters and kilograms. Can I do the calculation as it is? No, I need to convert. So if I have 2 liters, how do I convert that to milliliters? Use dimensional analysis. I don't want you to just multiply. I want you to show me that the units cancel because it's going to get complicated real quick. So you should have a good base. So my liters goes where? On the bottom, I put milliliters on top. How many milliliters in a liter? 1,000. Okay, so how many milliliters do I have? 2,000 milliliters because my liters canceled and I'm left in milliliters. Now, I have some gasoline that weighs 1.32 kilograms. Do the same thing. I'm running out of room. Goodness. I'm going to come down here. 1.32 kilograms. It's just the same thing. I'm just coming down here. So I want kilograms to go on the top or the bottom. What unit am I trying to get to? Grams, right there. I'm trying to get to grams. Okay. How many grams in a kilogram? 1,000. There are 1,000 grams in 1 kilogram. A kilogram is pretty relatively big, right? 2.2 pounds per kilogram. So that's kind of big, but a gram weighs nothing, right? Not nothing, but not much. So my kilograms cancel. What do I get? 1,320 grams, right? You're with me? Okay, now what do I do? Now I plug this and this into this guy, right? So I'm going to do it in blue. I'm going to say density is equal to mass over volume. So my density is equal to my mass. Which one's my mass? The grams. So 1,320 grams divided by my volume, which is 2,000 milliliters. So what do I get? 0.66 grams per milliliter. Running out of room. Now, because we multiplied both by 1,000, you actually could have done it and gotten the correct answer, but it does not always work out that way. So you really need to do it the long way. Okay, I'm gonna erase this just so I can go back and do that problem now. All right. Now, what is the density of water? Anybody done an experiment in like your high school chemistry where you had to calculate density of water? Yeah, no, really? Never? Oh man, that's like a standard one. Of course, I love being in the lab. So the density of water is 1 gram per milliliter. And you don't have to go in and memorize a bunch of numbers. If there's a standard that I want you to know, I'm going to give it to you. So don't go around memorizing lots of crazy numbers. Okay, don't do that. I will give it to you. So density and specific gravity are basically the same thing. So if we have a specific gravity of ocean water being 1.025, is this more or less dense than tap water? What? More. Why do you think that's true? You have lots of things dissolved inside of the ocean, right? Including salt, all kinds of different things dissolved, and that will increase the density of that. So another example was a person's urine, right? A person's urine, you can look at the density of their urine and you can tell, are they dehydrated or not, because of the concentration of salts in their urine, right? It'll change the density. If you're dehydrated, are you gonna have a lot of liquid water in your urine? No, you're gonna have more dissolved solids because you're trying to conserve that liquid water, right? So it's the same thing. Okay, now, this is really fun. Pull out your old favorite conversions, right? If you look on your paper, one of them says temperature. You have to be able to convert between the different temperature scales. Now, I have bad news for you guys. The United States uses crazy units. We use the English system, right? What does everyone else use? Metric. So a lot of things that we're familiar with and we're comfortable using, if you go to Europe or somewhere like that, they're gonna have no idea what you're talking about, right? You're gonna give them the temperature in Fahrenheit. You're gonna say, you know, it's 100 degrees outside in Louisiana, and they're gonna be like, what? You know, they're not gonna understand that. So it's important that you can convert back and forth. There was a, I love this story. There was a NASA mission going to Mars many years ago, but it was a collaborative thing between the European nations and the United States. And people in the United States did calculations in English units. Everybody else did calculations in metric. And the United States did not convert those units to the metric system, but gave the numbers to the European nations to like use in their calculations. They launched the probe to Mars. Guess what happened? It burned up in the atmosphere because their calculations were wrong. So that was a whole lot of money that basically got flushed down the toilet because the United States didn't use metric. Right? Okay, so we have to be able to go back and forth. So what we're doing here is we're given a temperature in Fahrenheit, and we want to calculate this temperature in Kelvin. So go to your formula sheet. Do you have something that will convert from Fahrenheit to Kelvin? You can pull it up on Moodle. You can pull it up anywhere. So what do we want to go from? We want to go from Fahrenheit to Kelvin. Do we have a formula that does that? I don't see one formula that does that. I think we're going to have to use two. What are we going to have to do? Y'all got to have these formula sheets. You're going to go from degrees Fahrenheit to Celsius, degrees Celsius, and then from Celsius to Kelvin. Okay, so our formula to go from Fahrenheit to Celsius is degrees Celsius is equal to, and I'm just getting this off the formula sheet, degrees Fahrenheit minus 32 times 1 degree Celsius over 1.8 Fahrenheit. So what do? We just plug in right here our degrees Fahrenheit. So what do we get? Degrees Celsius is equal to negative 112 minus 32 times 1 over 1.8 degrees Fahrenheit. So simplify that. Negative 112 minus 32. What do you get? Negative what? 145. 3, that's 144. 144. Negative 144. Okay. Now times 1 over 1.8. That's not really a decimal. What do you get? Negative 259. Okay, that's in Celsius. Am I done? No, I'm not done. Go back to your formula sheet. I need to go now from Celsius to Kelvin. How do I go from Celsius to Kelvin? Kelvin is equal to Celsius, degrees Celsius plus 273. So Kelvin is equal to negative 259 plus 273. What do I get? What is it? 14. How much time we got? Okay. So it looks like obviously we don't finish. I guess what I'm going to have to do is push back our homework. I'll push back our homework because we didn't finish. We got to finish. So I'll update the calendar and I'll give us another class period to finish chapter 1, and then the homework will be due. So I'll go ahead and update that this afternoon. Okay. What number did we end on? We ended on. Let's see.
I was here on Tuesday, but I guess I did the iClicker.
Did you? Yeah, anybody need to sign in? Everybody okay on iClicker? So it was probably because you weren't signed in yet. Can you send me an email that says, Dr. B, would you check that I signed in on paper?
I didn't sign
Oh,
in.
you didn't sign in on
I
paper?
did the iClicker, but I must have did it wrong. And it says
Oh.
that. Yeah, it is the same thing.
Would y'all send me an email
Yes,
and I'll fix it?
okay,
And I'll
thank
fix
you.
it. Yep, in case something happens. I'm always good with that, just in case. Yes, ma'am.
Okay.
Don't trip over those wires.
Right over there. So you do this, I don't understand this part. Like,
Okay, so look, you gotta pull, here's our formula, right?
Yeah.
So you used the wrong formula here,
That's why.
because we want to solve for degrees Celsius.
Oh, okay.
Right, because here we're going from, am I right on this?
Yeah, of course.
We're going from degrees Fahrenheit to degrees Celsius to Kelvin.
Okay.
So we want a formula that will give us Celsius. Then we want a formula that will give us Kelvin.
Okay.
Yeah, no, it's just a formula thing.
Okay.
You're good. Well, I got another class. Yes, absolutely. Okay, I'm gonna end this.